Today I'll be going over how to create a basic Spring Boot server. There's no prior knowledge necessary. The only thing that you need to do is create a folder that you want to work out of and then open that folder in Visual Studio Code. So let's go ahead and get started. Alright, so what I'm doing right here is using the Spring Initializer to generate all the boilerplate and the dependencies that we'll need for the project. We're going to use version 2.4, Java. The group ID is, like the name says, it's the name of the group that the project belongs to. So I'm going to put my own name in, but you can put whatever name you want. The artifact ID is the name of the specific project that you'll be working on. So for this one, we're going to put SB Basics. We're going to use the jar packaging type, Java 11. Alright, now that we have our dependencies, we go ahead and generate the project. Click generate into this folder. And all this is doing is it's going to download all the dependencies and create the project structure for us. Press open. And now you see we have our full project, or at least the baseline that we need to get started with. So here in the main folder, we have the entry point for our Spring Boot application. This file is what kicks off the server and allows the client to communicate with our server. We have our resources folder, and inside that we have a static folder which will hold all of our static content like images, HTML, and JS files. We have our templates, which would have held our timely files, but we're not using that. The application.properties, this is where you can set different configurations for the server. We won't be using that. We have our get ignore, which tells the project to ignore certain files when sending it to GitHub. We have our build.gradle. Earlier, when we were picking the different dependencies and specifying different things about our project, all we were doing was filling this file out, but just through a GUI. And if you look in the dependencies section, you'll see the REST dependency, the starter web, the Lombok. So all we were doing was filling out this file. We have our settings.gradle file, which you can use to set different configurations and variables for Gradle, but we won't be doing any of that in this tutorial either. Now I'm going to show y'all what happens when you run the server in its base state. So once the logs tell you that it started the application, you pick a web browser of your choice, and then you go to localhost port 8080. And then we can see that it's up and running. So now you can click into the terminal and press Ctrl+C to shut off the server. In our SB Basics folder, we're going to create 3 folders. They'll be named Controllers, Models, and Services. These are the 3 main folders that we'll be working out of for the project. The controllers represents the different paths that the server will respond to if the client requests them. So we'll create our file in the controllers, and we'll name it main controller.java. Now to tell the file that it is a controller, we'll have to put this REST controller annotation. And all this is doing is telling the server that this file will be used to serve content to clients that request the files that we're about to specify. So here I'm showing you how to make a GET request or a GET path. We'll call this one test. And if you haven't seen these before, these are called annotations, the @ sign and the GET mapping and the @ REST controller. And what those do, those provide functionality, well, extra functionality to handle these REST calls. So now we're creating the function that'll handle the request So whenever a client requests the test endpoint, we'll return endpoint works. So I'll show you guys a quick example. Now we have the Spring dashboard right here on the left. That's our project structure. And we have the Spring dashboard. So if you press play, that'll run the server for you. And click into the debug console. Wait for it to say it started. We see it started. Open up our web browser. Go back to localhost, port 8080. But this time, we're going to put /test at the end. And now you can see how these REST routes work. I'm gonna stop it. So now that we know how the endpoints are gonna work, we can go ahead and get rid of this one. Now we're going to go ahead and create our model. We're going to call this user.java. The model is the representation of the type of data that we'll be passing around. So for this example, we're going to be passing user data from the server to the client, depending on what they request. So now we need to define what makes up our user, or what represents our user. So let's start to define the fields and the properties that will make up our users. We're going to make all of these private. So we're going to have a private string of username. We're going to have a private string of email. Another private string of password. And lastly, we'll do a private string a first name. So what we're doing here in this model is we're defining what makes up our user. So anytime that we're working with user data, we'll only have these 4 specific fields. Now if we had a database behind our server, which we don't in this case, each one of these fields would represent a column in the database. So you can think of the table as users, and each one of these fields as a different column that makes up that table of users. Now here I'm creating a constructor so that whenever we create a new instance of user, we can pass data into it and populate those different fields. Now you may be wondering why all of these fields are private. That's because in best practices, none of those fields should be accessible outside of the class itself. Or when we create an instance of it, none of those fields should be accessible outside of the object. The only thing that should have the power to change these fields in the model is the model itself. So that's why you create getters and setters to do that for you, which I'll go over here in a second. So all I'm doing in that constructor is the constructor function takes in parameters, and we're setting those parameters that were passed in to the inner fields of the model. Now normally you would have to write all these getters and setters. So if I wanted the username of the user, I would have to create this public function and then return the username that's stored inside of the model. But as you can probably imagine, this would get tedious if we had to do that for each and every field. We only have 4, but in real world scenarios, that would get really, really lengthy. So thanks to one of the dependencies I had you all download earlier, there's an easier way with this at data annotation. This generates all the getters and setters for you. So now there's just one less piece of work that we have to do manually. So back in the main controller, we can begin to build out the endpoints that we want to have in our final project. So firstly, let's do a get mapping, and we'll call this show one. This is when we want to get the information for one user. This is going to be a public method. It's going to return the user type to the client. Go ahead and name the function show user. It won't accept any parameters. And just putting a comment here for what we're doing. We're going to create a dummy user, or a placeholder user, I guess I should say, just to get the errors to go away from the IDE. So we'll go ahead and create a new instance of the user type. And remember when I was talking about the constructors? So here we're passing in the data to the user that we want the user to have. So the username will be test. The test@email.com will be the email. The bad password 321 will be the password. And the first name for this user will be first name. Oh, in Java 11, it's still strong typing, so you can use var or the explicit type of the variable that you're creating. But if you want to use var, the compiler will just infer the type of the variable. Now that we've created that user, we'll go ahead and return it. Let's run this. Oh, that's the wrong run button. Go back to the Spring dashboard, press run. So once we perform a GET request at the show one route, we should be able to see that user that we just created. Let's go ahead and put that in. And there you have it. We have that user that we just created. The REST controller annotation, it takes care of serializing the Java type to JSON so that the client can see it, the client being us. And just to show you guys that you can use the explicit typing tool, I'll change that var to user. Restart the server and you'll see that the result doesn't change. Just one of the perks of Java 11 and newer versions as well. Now we can begin to build out the rest of the functions that we want. So let's create another get mapping. This time we'll call it show all. We'll use this endpoint when we want to return all the information on all the users that we have to the client. This method will be public. And since we want to show all the users we have, we'll be returning a list of users. We'll go ahead and name this show all. This function also won't take any parameters. Now to get rid of the errors, we'll just create a variable users and set this equal to a new array list of type user. The nice thing about array lists is that there's no size limit, so we can add to it as much as we need to. And what I'm doing here to get rid of the red squigglies, I'm pressing Control space and it's auto importing the necessary dependencies. You may also be wondering why the function return type is list even though we're returning an array list. Well, that's because array list implements the interface list, so it's perfectly legal to return an array list in this function because due to array list implementing the list interface, it still satisfies the return type of the function. Now we're going to work on our next endpoint. This time we'll be doing a post mapping. We're using a post mapping because we're expecting the client to send us data, and then we'll do whatever we need to do with that data. So we'll call this route add-user. Make this public. For this one, we'll just return a string saying that the user was added. Now for this function, we will have parameters. We'll start it off with this annotation at request body. The type of the request data coming in will be of type user, and we'll call the data coming in new user. Now what this annotation does is it looks through the request data coming in, and then it tries to serialize that data into the model that we've specified. So this function is expecting JSON or XML, but we're using JSON in this case. This function is expecting JSON data that mimics the user model, and if it mimics the user model and has all of the fields in our user model, it'll turn that JSON data into a Java object so that we'll be able to work with it like I'm doing here. Now we're able to call this getUsername function because request body annotation has serialized the JSON data into a Java object that we can work with in our code. Here we'll go ahead and return the username back to the client. We'll need to do a little bit more than this, but right now I'm just setting up everything so that we can start to get a feel of the structure of the project. So I skipped ahead a little bit, but right here I've just made another get mapping, delete-user/username. You can see in our function we have a parameter named path variable that we're also calling username. This is the way that you grab variables from the past, so nothing that we haven't done prior. So now we're going to go in our services folder and create our mainservice.java. This is where we'll handle all of our business logic. Let's create some comments. We're not connected to an actual database, but there is a way for us to have a central memory location, so to speak. This is where we'll store all of our users, and this is where we'll be returning the users from to the client. So we're going to make a list of type user, name it user database, even though it's not a database. We'll just specify the type here. Import our user model. And we're going to go ahead and make this private and static so that we can ensure this database is only created one time. We're also going to make a static singleton so that this service class is only created one time. Now I'm doing it like this so that we don't have a bunch of different copies of our data floating around throughout our code. We only want one object handling all of our business logic, and this is the way to do it. Well, one of the ways to do it at least. I'm going to make a private constructor. We're going to have a public static method. The return type of that method will be Mainservice, which is the type of our class. We're going to call it getSingleton. This method is to ensure that this class is instantiated one time and one time only. So we'll do a quick check here. We'll see if our singleton has been created already. And if it hasn't been created already, We'll go ahead and instantiate it. And then we'll return it. We're also going to do the same thing with our user database to ensure that it's created one time and one time only. So we're doing a null check. If it is null, we'll go ahead and create it. And just a little research tip for you guys: look up singletons and the pros and cons of making and using singletons. This will help you a lot throughout your development career. We don't necessarily need to return the user database. We'll only be working with that user database within the class, but we do need to return the singleton, because if we don't, we'll have no other point of entry to the functionality of the class. So what I'm doing right here is just showing you guys how we'll get to the inner functionality of this class. So we'll make a test function, have to return a string just to prove that our singleton is working. We're back in the controller. Now we have to import that service class, create our singleton, and then through that singleton, we'll access the functionality of the class. So we'll declare our class variable. And you see we have our get singleton class. So now that we have our singleton instantiated, let's create another get mapping. This one will return the string from our singleton object. So the return type of the method is string. Then we'll return service.test. Let's run the server. If I can find it. Put in our base route, and now we see the message from our singleton. So we know our service is working properly, and we can start to work on some of the other functionality that we'll need. Go ahead and get rid of that method. Now we'll create our add user method. We'll use this to add new users to our user store. This function will have one parameter of type user, and it'll be the new user object that we want to add. We'll have the return type of the method be true or false, and we'll return the result of the add function. This function will return true or false based on whether or not the program was able to add the user to the array list. You can see it right there. Alright, so we're going to work on our next method now. This will be public. The return type for this will be a list of users. So you can probably guess what it is. We're making our show all method. And this method will grab all of the users in our data store and then return that back to the controller, which will return it to the client. So the only thing we need to do here is return our user database variable. Then we can go down to our show all users method. We can get rid of this and change that to our show all method. Or if we really wanted to get concise, we can go ahead and delete all of that and then just return the function itself. Be the exact same thing, but just one less line of code. Keep it simple as much as possible. And since we're here, let's go down into our add user method. Throw this comment in there. Now let's call our add user method and pass in the new user that the client sent to us via the REST call. Now remember that add user method returns a true or false value, so let's play off of that. Success equals that method. And now the success variable will be our determining factor to pick what we send back to the user. So if success, we want to return this string to the user because their user was successfully added to our data store. And in the event of failure, we'll return a different message back to them. Now, normally in large-scale production-grade applications, you'll do some error checking, you'll have some fail-safes, but just for the sake of this tutorial, we'll just leave it at this. Now let's test it out. So we've got our server running. And remember, this is a post mapping, so we'll be sending a body containing that user to our server. Now here what I have is Postman set up online. I'll drop the link below. This is a tool to send different type of data to servers that you're building or servers that you're working with. So we're going to new, we're going to create a collection. We'll use this collection to store all of our related requests for this specific server. So let's name this collection Spring Boot Tutorial. Now let's start to put some requests in it. So we'll go here to new, request. Let's make this request for add a user. We want to save it in our Spring Boot tutorial folder or collection, whatever you want to call it. Make this a post, put in our endpoint. Now let's begin to construct the body of our request, aka the data we're sending to our server to work with. And remember, this post mapping at add user is expecting JSON data that exactly mimics what's going on here in the user class. Now we have our username spelled exactly like we have in the model. And we have to do it that way so that Spring Boot knows to match this JSON object with our user class. And it'll take care of serializing this JSON data into the user class or user type for us. And I say a little password. Its name. Now let's see what happens. Oh, so you're gonna need this desktop agent. I already have it downloaded. That's what it'll look like once you download it. And then once you do have it downloaded, you'll double click, make sure it's up and running. And then you should be good to go. Let's go ahead and press send. Okay, we got an error. Conversion exception. So we know that this has to do with converting that JSON data into our Java object. You see what it's trying to convert the JSON data into, our user model. Cannot construct instance of blah 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 dot user, no creators, like default constructor exists. Cannot deserialize. Okay, when you see that, that just means we didn't perform a call to the default constructor. And I'll show you how to do that here. So if you ever get that conversion error, you'll want to start with this and make sure that this is in the model that you want to turn your JSON data into. So now that we have that, let's try it again. And we have our message that confirms it was added. All right, let's go ahead and save that. And now that we know that works, let's move on to our next endpoint. So this one will be for show all users. We're gonna save it to the same folder, Spring Boot tutorial. Now this will just be a GET request because the server's not expecting any data to come from the client. There's our show all endpoint. Oh, and to note, since we don't have a database behind our server, we'll have to add those users in each time we turn off the server and start it again. But since we didn't, I added a user in the meantime. I just cut it out, so you should only have one if you did it once. But I added 2 of them, so here they are. And we're going to create our next endpoint. Delete the user. Save it. Now we can create the GET request for a deleted user. So localhost port 8080/delete-user. And then at the end of that, we'll put the username that we want to delete. But first, let's go ahead and begin to construct this method. So we're going to make another public method. It's going to return a Boolean, so true or false. We're going to name it delete user. And this method will accept one parameter, that parameter being username. So we're going to have our success variable and we're going to set it to false initially. And then we'll have our user to delete. So what we'll be doing here is looping through, iterating through our array list of users, and we're going to look for the user that matches the username that we're passing in. Now this is a very, very basic way to do it, and also when we're adding our users in, we have no way of making sure they're unique, but just for tutorial purposes, whenever we're adding users to the user database variable, we'll just pass in different usernames. Now what I'm using here is an enhanced for loop, and it's going to go through our user database and it's going to grab each one and it's going to put it in that user variable, and we can use that variable to work with each user in our user database. So right there, what I'm doing is if the username of the current user that we're on matches the username that was passed in, we'll set that user to delete to the current user variable. So now we'll set this success variable to the result of whether or not we were able to remove the user that we may or may not have found from the user database. Just like the add method that we used earlier, the remove method returns true or false based on whether or not it was able to successfully remove the user. So if the user to delete is set because we do find a user whose username matches the one that we passed in, we'll be able to successfully complete this operation. But if the user isn't found, then the remove method will just return false. Now let's take this out of there. So we're gonna do like we've been doing and play off of the true or false way. So we'll do our service.delete user, pass in the username of the user that we want to find. and that method will return true or false. So if success is true, we want to return user passing their username was deleted. And if success is false, we'll just say failure occurred. If you're not familiar with this style of if operators, this is called the ternary operator. So it's just a way to do an if statement in one line. All right, now we back in Postman. So before we can even test out the delete user, we gotta put some users into our database. So let's send this one. Now let's change up the username because the username has to be unique for our little code base to work. Let's add him in. Let's do one more. All right, now let's confirm that all the users we added are in our database. Remember, I'm using that term database loosely. We're really just showing the contents of a variable. All right, now we can see we got all three of them. Let's grab that one, that middle one. And that's who we will try to delete. It says that he was deleted. And now it says failure occurred because we tried to delete him twice when he doesn't exist. And there you have it. So now we're gonna go ahead and create another post mapping. We'll use the Visual Studio Code generated one for this one, and the path for this one will be update user. So we'll use this endpoint to change the information that we already have on an existing user. So the return type of this method will be the user. We'll name this update user. We're gonna keep the parameter that came along with it because in this post mapping, we're expecting the client to send us the new user information at least. So now that we're back here in our service, let's go ahead and create this method. This time we'll return a user from this method. Little typo. We're expecting a user variable of type user. We'll name this updated user. Let's come back to the service. So this method is going to be pretty similar to the remove user or delete user method because we're going to iterate through our user database variable the same way. And the only difference being that this time, if we do find a user, we'll grab the index where we found them at and then replace that user with our new user object. So now we have a variable storing our username, and now we will create a variable that will store the index of the user that we want to update if it exists. So we're going to do our enhanced for loop, and we're going to iterate through these users and check each user's username field for a match. And we need this get username because we can't directly access the username field. So we just return it, and then we do this equals function to see if it matches the username of the user that we want to update. So now that we found a match, well, if we find a match, we're going to set the index variable to the index of the user whose username matches. Index of, and then we pass in the current user. So if we find a user whose username matches, then we'll store the index of the current user in our index variable. And now that I'm thinking about it, let's add one more thing in here just to make it a little better. We'll put this user found variable in. We'll set it to false initially. So if we do find a match in our user store, our user database, we'll set that to true. And then we'll check our user found variable. And if it's true, then we want to go back into our user database variable and set the user at that specific index to our new user. So we're replacing the object at the index that we found earlier with a match to our new object. And once again, we'll do our return based off of our true or false variable that we have set. So we're going to return if user found is true. You know what? Let's change this method's return type to a Boolean. So if user found equals true, we're going to return that. And if user found is false, we're going to return false. We'll keep this one as a user so that they can see what they just added. So we're going to create a user found variable again, and we're going to set it equal to the result of the update user function. And then for that function, we'll pass in our updated user. And I'm going to speed past this little section, but what I'm doing here is just constructing an if statement. So if user found is true, we'll return some message saying that the user was found, and if it's false, we'll just return that the user was not found. So now go ahead and run the server again, and we'll test out the new endpoint that we just made. Everything looks good here. Alright, so now what we have to do is create our update user request. Save it in our Spring Boot tutorial folder. Change that to a post because we'll be sending the new user data. Now let's add some users in so that we can test out our other endpoints. So we see that was successful. Let's give this one another unique username. That was added successfully. Let's do one more. Alright. Now let's hit our show all endpoint to make sure we have all of our users, and we do. So now we can move on to the next step. Let's take this second user, copy it, and we'll put in our URL again, but this time with the update user path added at the end. We'll put this body in, and we'll just change a few things. Change email to test, change it to JSON. Let's change the password to a good password. First name, just so there's no confusion there. Okay, we can see that user was updated. Now this is what it used to be, and we can see that our update endpoint works. So that's all I have for you guys in this video. I just wanted to go over some basics of building endpoints in Spring Boot and how to work with Postman. These are some skills that I believe are real foundational and they can take you far. So thanks for watching and stay tuned.